Okay, so a few weeks back, Patrick also did a Bhyve session. He covered a lot of the lower layers, comparing to KVM, explaining why Bhyve, giving some performance numbers, and got into a little bit about images and guest configuration. And I will try not to repeat what he said, but there will be a little bit of repetition just as background to get into more depth. His presentation is available on YouTube. The link is found below. So a key thing that we introduced with Bhyve is the notion of hybrid machine image. Hybrid images are intended to work with KVM and Bhyve. The idea here being that why do twice? We can do it once. And it has some other nice features that I'll get into in a bit. The key differences between a KVM image and a hybrid image are that the hybrid image will configure SDC NICs, or I'm sorry, configure networking using the SDC NICs, SDC resolvers, and perhaps other information from the metadata service. This typically means that we have cloud-init in the VM or in the image, and it will know how to do that. In the case of Windows, we don't actually have hybrid images, but if we did, PowerShell could be used, or as we're introducing things like FreeBSD or something like that, we probably won't use cloud-init because I don't think it's ported there. So we'll wind up just with some boot script that talks to the metadata service directly, and then does the necessary configuration. Hybrid image also probably uses a serial console, and the console isn't really required unless something breaks and you need a console to fix it. Most Linux images that have been created after, say, mid-August are hybrid images. To tell whether you have a purebred or a hybrid image, I don't know if purebred is the right one, but sounds, we'll run with that. You can look at the image manifest. If the image manifest has a brand and it says something other than, well, if it has a brand property, that means it is a purebred. If it does not have a brand property, it means it's hybrid. And so, you know, brand could be KVM or Bhyve, and ignoring the various container images out there. So the typical creation steps for a hybrid image are to use KVM, primarily because we have not implemented all the niceties that QEMU has around being able to specify a one-time CD-ROM and boot order and things like that. We'll get there, it's just not there yet. So hybrid images are still created on KVM. We need to include cloud-init 18.3 or later in general. Ubuntu 16.04 and 18.04 recent versions of it anyway include cloud-init 18.2 or later. The version of cloud-init 18.2 actually has the fixes that are needed that first made it into 18.3. So they picked a development snapshot that included the fixes, or they have backported things. So aside from getting cloud-init into the image, there's also getting grub into the getting grub configured so that that it uses the serial console. So we want to have in general, well, hybrid images must use biosimulation, so the UEFI CSM, but that lacks proper VGA support. And so that makes it so that we really need to have the console directed elsewhere. If you're wanting to look at how the various images are built, take a look in the Joyent project in GitHub. The various mi-distro-bhyve-version is used for creating the various images. In the case of Ubuntu, we get those images from Canonical, and we just fix the console in them. There's not actually a repo that has the fixes in it. Okay, so I mentioned cloud-init. It's primarily developed by Canonical, which is why it wound up in the Ubuntu images, because they provide them and they provide cloud-init, and they like to dog food. If you read the cloud-init docs, you'll find that cloud-init is the de facto multi-distribution package that handles early initialization of a cloud instance. And yeah, I guess that's pretty accurate. It essentially has some boot scripts, a boot script or some boot scripts, depending on the version. The system decomplicated things. So it reads from various metadata services, puts that into an abstract form internally, and then sends that abstract data to various distribution-specific backends that can place the configuration into the right place. So, DNS on configuration on Ubuntu is different than it is on CentOS, and it knows how to do the right thing. So the cloud-init has been used for some time with KVM images, but the version that was there when we started the Bhyve project didn't work so well with Bhyve. It used the v1 metadata protocol, which doesn't have some of the niceties or some of the safeguards that are needed. So to make cloud-init work with Bhyve, we needed to implement the v2 protocol. So essentially that adds flush negotiation. So when the metadata serial port is opened, it first reads all the data that it can, and I think it sends a new line and expects to get an error message, and then it negotiates the version, and then all messages are checksummed. V1 might have been checksummed as well, I forget. The problem was that somewhere between Bhyve, the boot ROM, or Grub, something was spitting out a few clear screens onto COM2, and that was screwing up the first get that was being sent. And the first get that was being sent was the network request for SDC NICs. We also had various bug fixes and probably some minor feature additions that that were helpful in getting it to work well. The non-Ubuntu distros have not had the emphasis on cloud-init that Ubuntu has. The Canonical folks have done a great job of being sure that it works with other distributions, though. So I largely took their work and figured out what was required to make it so that we had proper build environments on machines on the different distros. Put that into a README that's in the Joyent Bhyve branch of the cloud-init fork that we have, and so built packages for that for various CentOS versions and Debian, and I think Ubuntu 14.04. I don't think they updated. They've done recent updates to cloud-init in 14.04. Aside from installing the package, I need to do one extra step, and this is done by the image creation automation already. You don't have to do a special if you're using that automation, but if you're installing cloud-init onto an existing machine, you will want to edit the data source list. So the etc cloud.config.d directory can take config files. They must end in .cfg that have various YAML configuration that can be used to influence the behavior of cloud-init. If you do not have this in there, it will go through all of the data sources that it knows about, and some of those do things like rely upon a link local address to be able to query information from metadata service. So an example of a cloud that does this is OpenStack. If you have a network that's working a little bit, that will cause very long TCP timeouts and with many retries, so you can sit there for 20 minutes or so waiting for all the timeouts before it reads the SmartOS config. So as I mentioned before, the serial console is needed if we are using biosimulation. The guest should redirect to TTY S0 or TTY-A or COM1 or whatever it wants to call the first serial port. On Linux distributions, this is most commonly done by editing etc default grub, at least those Linux distributions that are using grub 2. So paste the lines I have there into that file or an etc default or etc grub.d whatever file on Ubuntu, and then update the grub configuration using update grub 2 on Ubuntu or grub 2 make config on others. Update grub 2 on Ubuntu takes no arguments. Grub 2 make config takes some arguments. Look at the man page, please. And so the console is connected by Bhyve to the dev Z console that Bhyve is running in, or in the zone that Bhyve is running in. So that makes it so that the zone console for Bhyve works just like all other brands, except for KVM. KVM does something special and makes it so it doesn't work with zlogin-c. Bhyve will work with zlogin-c or vmadm console. Beware that if using vmadm console, that to terminate your console connection, you will need to use the same sequence that you use with any other brand aside from KVM, and that's control right bracket dot, not just control right bracket. Like I said before, the graphical console only works with UEFI without the CSM. KVM doesn't support UEFI, so we try to avoid it so we can have hybrid images. But the Windows installation really wants a graphical console, and we weren't having a lot of luck creating a hybrid image. So we went with a specific Bhyve image for the various Windows versions. The Bhyve VNC implementation is really a bare bones implementation. Unlike QEMU, it does not provide an alternate console implementation with Spice. So VNC is your one choice. The implementation has limited or no choice in color, depth, compression, resize, etc., and that confuses some VNC clients. In particular, the VNC client that's built into macOS does not work. VNC Viewer from Real VNC and Chicken of VNC are reported to work well. But in general, the console is only used for by operators. It's not plumbed through in Triton anyway, so this is, the crappy VNC implementation probably isn't a big deal for cloud deployments. Another thing that's different with Bhyve is the storage layout. So in KVM, the VM's disks were not nested underneath the zone path data set. with Bhyve they are. That was something that was caused a few problems with KVM and wound up having a few Jira tickets filed for it. That has a lot of impact on how we manage quotas and reservations. Like KVM, over-provisioning really is not an option. We got some of the reservations on volumes wrong on KVM, so you could actually end up into a out of space issue on KVM disks. That's been resolved with Bhyve. When you have a out of space in the host, that turns into an EIO in the guest. And if a guest hits a situation like this, they really have very little recourse. They can't remove files and free space, like if they're in a native zone. Their only hope is, trying to write again, and maybe next time it'll overwrite something that the guest had previously written. But that's a pretty poor approach. So we want to guarantee that the space is available, and that can be accomplished via a couple properties. A reservation is set on the zone path data set, and that makes sure that a certain amount of space is available to the zone path data set and all of the data sets that are its children. So that's the aggregate space for them all, not the individual space. And then there's ref reservation, which is how much space is available to, or how much space is reserved, I should say reserved for that, not necessarily available. That speaks more to quota. So ref reservation is the amount of space that a data set is guaranteed to be able to use. And as a reminder, the ZFS term data set is often interpreted to mean file system. That's not necessarily correct from ZFS source codes or I believe man page standpoint. A data set can be a file system, a volume, a snapshot, and perhaps other objects that come along in the future. So in order to limit the amount of space that's available to a particular data set or data set hierarchy, we have quota and ref quota. So quota will apply to a hierarchy. So we set that on the zone path data set, and ref quota can apply to a particular data set. So if you combine quota, ref quota, those can actually make it so that you can't write to the entire space that's been reserved for a volume. No, potentially, I think that it actually prevents you from setting a quota that's smaller than vol size. But in any case, quota and ref quota aren't really needed on a volume that has vol size set. So we tend not to set it there. Let's take a look at what a typical zone looks like. This is a zone that I installed on East 3B and munged the output a little bit to make it so that it fits on the screen nicely. We'll walk through what all this means. So on the zone path data set, we have quota and ref reservation that match. This means that the instance will be able to write as much space as it's been allocated. So there's not somebody else that can come along and fill up the pool and steal space from this zone. And then we set ref quota and ref reservation on the zone path data set to the amount of space that we expect the zone path data set to use. So this is only used for things like files in the logs directory and the config directory. In general, those should be fairly small, a lot smaller than 10 gig. When we get down to looking at the disks, we see that the vol size and the ref reservation don't match. So like I said earlier, with KVM, we sometimes got the ref reservation wrong on a disk, which made it so that when you filled up a disk, you could get into a situation where not enough space was reserved. If the pool is full, you could get EIO, or if you're hitting a quota somewhere, you could also get an EIO. But so by setting the ref reservation to a bit bigger, we ensure that we have space for metadata. The definition of a bit bigger is already automatically calculated when you set vol size equals auto. So you set vol size equals auto, and then you do a ZFS list or ZFS get, and it shows you the actual about. It doesn't say auto. We also have some code in Node that implements the same algorithm. So if we need to do calculations in Node, we can. This is used, I think, mainly in some test code to be sure that we're setting it as we expect. So the quota and ref reservation turn out to be the sum, or I'm sorry, the quota and reservation on the zone path data set turn out to be the sum of the ref reservations for the entire hierarchy for the zone. So, you know, numbers have been rounded there to make human-friendly numbers, but if we were to look at the non-human-friendly parsable numbers, if we were to look at the parsable numbers, I guess, you'd see that those add up directly. This has a side effect that you can do ZF or DF on the zone path data set, and that will actually show you how much space is used and available there as well. The 80 gig for the disk 1 corresponds, and this is the same thing that happens on KVM, corresponds to the disk property in the package. And the disk property in the package is commonly presented in the in admin UI and the user portal as quota. So don't confuse quota in admin UI or user portal with the actual quota on the zone path data set. Those are different things. You know, 81920 and 80 gig are the same. It's just megabytes versus gigabytes. So if you're debugging, don't follow the lead of my sister with a handful of bees. Do something different. You're going to, if you need to interrupt the boot process and twiddle with something in grub or similar, you can use zlogin-c. That's generally more friendly than vmadm console. zlogin-c can start before the VM starts, and it won't get disconnected when you halt or reboot the VM. Some images may have grub set to silent, so you'll need to hit escape or enter or space, one of those three, to get the grub menu to appear. There are some helpful logs as well under in the zone path /logs. There's console.log. Anything that is printed on the console is recorded in there. It's a JSON log, not Bunyan. Should probably convert that over to Bunyan, but it is time-stamped and parsable as much as you can parse console output log or console output. The platform log is in the same directory, and that will have various information from zone ADMD and anything that Bhyve writes to standard out or standard error. So a common problem that Bhyve may spit out is I didn't have enough memory. So if you find that you try to start a VM and it doesn't start, you can look in there, and if that will be a good place to find a pretty clear message that the reason it didn't start was because it couldn't allocate the memory. Many people have asked about a path from KVM to Bhyve. if you're using a hybrid image, it's already that's already designed for the pass from KVM to Bhyve. There shouldn't be anything really special you need to do inside the guest. If you're changing, if you're making big changes like this, you probably want to create a backup. But honestly, I never haven't lost anything. But you definitely should create a backup. The easiest way is to create a new Bhyve instance on the same compute node. Don't boot it. Move the disks. You can use this little bit of shell, or you can do something else that accomplishes the same. Essentially, you need to move the KVM UUID dash disk whatever to Bhyve UUID slash disk whatever. The NICs will need to be fixed up, and then you're able to boot the Bhyve instance. Trying to do a vmadm update of where you create duplicate IP addresses will cause the vmadm to complain, so you'll probably want to destroy the KVM instance, fix the NICs, and then create the Bhyve or boot, and then boot the Bhyve instance. If you're destroying your KVM instance, just be sure that you do a vmadm git or something like that beforehand, so you have all the information you want out of it. That's part of the backup. If you are trying to get into Bhyve and you have an old instance, this can also be done. It's it's kind of a, if you break it, you keep both halves. I mean, this is not something that I think we're eager to support, but in general, it is possible. It's what we did in early days before we had images. So essentially, the idea is you update whatever packages are on the machine to be sure you're kind of current. We just haven't done any testing with really ancient versions of CentOS or Debian that don't know what kind of other problems you might run into. If you're relatively current on fairly modern distributions, you should be in good shape. You're going to need to have cloud-init 18.3. If you're on Ubuntu 16.04 or later, just whatever is latest from their updates repo, you should be good. If you think that you might ever need to fix something on the console, you'll want to get the console fixed so that you can log in through zlogin-capc or through vmadm console. Then do what I described on the previous slide. If you're coming from other OSs, this is less not as smooth of a path. So if you have anything with ZFS root, it's probably going to be unhappy because ZFS is intolerant of the root pool's disks moving around. This is something that can be fixed. I fixed it in Solaris. I believe that there's other efforts out there to fix it in Illumos, but I don't think it is present in Illumos or any of the downstream distros. And if you're on pretty much anything non-Linux, it probably doesn't have cloud-init. I don't think that cloud-init supported anywhere else. And it probably doesn't have anything that is looking at SDC NICs and friends to figure out how to configure the networking. That's kind of an exercise left to the reader at this point. And all of this is fixable. It's just we haven't gotten there yet. So if you're wanting to create a Bhyve instance in SmartOS, it is pretty much the same as what you do with KVM. Very similar to what you do with other brands. Be sure you have a proper image. I described how to tell the difference between a Bhyve image and hybrid image and others earlier. in the payload that you pass to vmadm create, you'll want to be sure that the brand is set to Bhyve. And then just use vmadm create as you normally would. You can use imageadm to create derivative images, and should be pretty unsurprising in the way it works. There are a few other differences. Like I mentioned earlier, Spice isn't available on for the console, and there's a few other things that are a bit different. But for the most common use cases, it's just the same. Take a look at vmadm. It lists the things that are common to HVMs and breaks out things that are KVM versus Bhyve where appropriate. If you're wanting to create a Bhyve instance with the Triton CLI, you'll want to be sure that you have a package that sets the brand to Bhyve, and then just run Triton instance create, and that will finish in a little bit. And then you can SSH into your box, and you can verify that it's Bhyve by looking at the boot messages, or there's probably some other ways too, but that was the easiest way I found. So when deploying an image through Triton, there's not a whole lot of magic, a little bit of magic. So it does verification that package.brand is set to Bhyve if you're, well, I'm sorry, if package.brand is set to Bhyve, then it makes sure that the image requirements.brand is either undefined or set to Bhyve. Once that passes, DAPI will be charged with finding a suitable CN. It has additional step that if packages.brand is Bhyve, it needs to make sure that the machine can run Bhyve. That information is passed up to CNAPI through information reported from sysinfo. There are a couple new fields there. Bhyve capable. It needs to be set to true, and that is true if the hardware, the CPUs support VMX and EPT. And then Bhyve Max vCPUs needs to be a compatible value. And DAPI does all the other normal things that DAPI does. And once DAPI finds a suitable machine, the VM is provisioned just as it normally would be. Of course, it uses Bhyve brand installation scripts instead of KVM brand, but those are pretty similar aside from like the disk layout changes I mentioned earlier. So we're getting towards the end here. A couple interesting links. Patrick's part 1 of this series is available on YouTube. A few days ago, Shane Peters, SmartOS fan out there, has been playing around with getting Kubernetes to work on SmartOS with Bhyve, and that also includes using cloud-init to customize Kubernetes, and so that's I guess an interesting lesson in what else you can do with cloud-init, aside from being something that will make it so that we can do just the internal plumbing that we expect to be able to do. It also makes it so that we can set user data to have cloud-init YAML, and that gets passed in, and cloud-init will pick that up and do interesting things with it. It's a good use of 15 minutes of your life to watch that. So there's other Bhyve work that I have not covered today that is just wrapping up. So there's some storage management changes to support snapshots, variable number of disks, disk add, remove, and resize. And then there's also instance migration, not really specific to Bhyve, supports Bhyve, and expect to have future JTDs on this. And with that, I am at my picture of warnings about beehives in a lava field, and I never saw a bee there.
Where is that, Hawaii?
Yeah. I took that picture as I was standing around a family full of beekeepers, and we all laughed. All right. Well, if there are no questions, we will call this a day, and you'll be able to find this on YouTube shortly. And oh, looks like there might be a question coming in. No, Max was typing, but he stopped. Okay, so all right, we will call it a day. Thank you, everybody.
Thanks, Mike.
Thank you.
Thanks.